Well, happy to have you here. A warm welcome to Elmia on behalf of the entire group of Wieland. Another Wieland group right beside here. Our booth is in Hall D, so please visit us there. Today I will speak about the topic of lead-free machining brass solutions with a focus on the application of drinking water and the regulations around that topic, which forces us to get lead-free within the next 5 years, more or less. So, first topic would be why are we using lead in brasses? To see the background, what's the purpose of using that lead, and look at the regulations, what is forcing us to get there, as well as, of course, some solutions of the Wieland Group to get there. If we talk about machining solutions in the brass selection, we have 3 elements which are quite important for that. We have the copper, the zinc, and of course some lead in the alloys. The lead content is between 2 and 4% of all the standard brasses which are used for the machining all over the sectors. If we just erase the lead in the alloys, we are facing some machining issues. So we will face on drop in the machining, in the performance, and at the end of the day in productivity. So we have to look for some other elements we can put in the alloys to substitute the lead, which is not harmful to the environment or harmful to human beings and other surroundings. So there are some elements which are quite good in terms of machining. We can, for example, use an element like bismuth, but such elements are quite detrimental if we look at sustainability and to keep scrap cycles working, because such elements like bismuth or tellurium are quite bad in terms of embrittlement if we look at bronzes, and that's why we have to avoid elements like that. Wieland is focusing on silicon as a chip breaker, but more on that later. So if we like to substitute the lead, we have to look what is lead doing in the alloy itself. So of course, it is a solid, it is a chip breaker as well as a solid lubricant during the machining process, and that's why we achieve such a high machinability of leaded brasses, and that's the aim of all alternatives, to maintain that high productivity level. But before we come to the solutions, I would give you a short overview of the regulations which are forcing us to go there. Basically, lead is classified as a substance of very high concern since 2018. Since that, it's mandatory that all products with a lead content of 0.1% or higher are marked and communicated during the whole supply chain. So you have to communicate if you use leaded brasses during the whole supply chain that there are detrimental substances in there, for example, in this case, the lead. If we look at the regulations in detail, we can see that the regulations are usually linked directly to a specific application. If we go from top to down, we see the ELV, the end-of-life vehicle. This regulation aims to the circularity of end-of-life vehicle. So at the end of the use of the car, it should be recyclable, and that's why the regulation aims for not using elements like lead which are of concern. So at the end of the day, we have to recover all the material, and that's why we shouldn't use materials that are harmful at the beginning of the product life. Basically, there is a lead limit of 0.1% also in the ELV stated, but there is an exemption valid until 2025. So we have 2 more years to go, more or less. However, if we look at the exemptions will fail if more and more lead-free alloys are on the market. So today I will show you we are providing 2 new alloys in the coming year, and so it is a question how long the exemptions will stay. So I guess they will fall within the next years. If we look to the electrical business, restriction of hazardous substances, there is also a lead limit of 0.1%, and currently there is an recommendation from the consultants, the Öko-Institute, to the European Commission to extend the exemption with leaded brasses up to 4% in lead content until 2026. But also here, it is not sure how it goes after that. So it is also possible that this will be the last exemption, and after 2026, it will be over with the leaded brasses in this business. Coming to REACH, it is more a holistic regulation because it covers all the applications. There is currently a recommendation of the ECHA, the European Chemical Agency, which is the consultant of the European Commission in this case, and they recommend to set the lead on the Annex 14 of the REACH regulation. And what this means, we will see on the next slide. The probability of the inclusion on Annex 14 is not too high at present, but we will see it in the next year. I guess the European Commission will decide it next year. It's not sure, maybe they will also postpone it to 2025, since in June next year there are the elections of the European Parliament, and that's why maybe they will decide it in 2025. If we look at the two different systems of the REACH regulation, on the left-hand side we can see the restriction. That's what's valid today. So we can find the restrictions in Annex 17. What is it about? Basically, it means everything is allowed, so there is no ban on the use of lead, except for some special applications. In this regard, it is jewelry, watches, some consumer goods, lead shot ammunition in wetland hunting, and all parts that can be put into a mouth of an infant. So these are the prohibited uses, but everything else is okay. If lead is put on the Annex 14, it will be forced by authorization. And here the logic is quite different. Everything is forbidden except for uses which a manufacturer aims for an authorization. So in this process is quite time-consuming and at the end of the day very expensive. So it's also worth here to switch to the lead-free alloys before lead is on the Annex 14. If it is decided that lead will be put on the Annex 14, we will have around about 5 years, so 2029, 2030, until authorization is needed. So we have some time, but we have to think about solutions which are lead-free. Coming to the last slide regarding the regulations, we will take a look at regulations all around the Drinking Water Directive and the European Chemical Agency's European Positive List on metals. The Drinking Water Directive was published beginning of 2021 and had to be transposed into national law until beginning of this year. So what is the biggest thing regarding the Drinking Water Directive? The Drinking Water Directive reduces the lead content, which is allowed at the end of the day at a tap, from 10 micrograms per liter down to 5 micrograms per liter. And the proposal is to do this until 2036. The European Positive List will be published beginning of next year. On the European Positive List, you will only find alloys which are capable to maintain the 5 microgram at a tap. So this would be a real future list in regard to metal and leaching. If we look at that at a time, we see beginning of this year, the Drinking Water Directive was transposed into national law. And as I said, we have the 5 microgram value valid from 2036. For example, Sweden followed this rule and set the 5 microgram to 2036. But there are some other countries like Germany, and they did something else. They they took the date and put it to 2028. So in Germany, it's mandatory to have that value valid from 2028 on. What does this mean for us? If we provide alloys and products on the German market, for example, they need to be lead-free or on the European positive list quite before that time, because the 5 micrograms is valid at the tap, and you know there are some times in stock, some time delay, there is some delay due to the building phase of products, and that's why basically if you are active on the German market, you should switch your product portfolio at the latest by 2026. That would be my recommendation for you. Going to the other topic, the European positive list. The European positive list will substitute all the national regulations regarding what is okay, the NKB in Sweden or the 4MS positive list in some other member states of the European Union. And it will be published beginning of next year and will be valid latest end of 2030. So after the 31st of December 2030, only materials according to the European positive list will be capable to be put on the market. That's why that's almost the last date where you should put products with lead on the market. Good. With all this knowing, we set up some product lines for the different applications and to maintain conformity with the different regulation. We have the ecoline water line, which maintains all the requirements from drinking water directive. We have the connect, which takes into account all the RoHS requirements, in this case 0.1% lead level, for products like connectors or electrical terminals. So in this product line, it's very important to have a high electrical conductivity, for example. We have the drive eco portfolio. Here we have some bushings, battery clamps, tire valves, and so on. There are all other requirements like corrosion resistance for the tire valves, if we look at that. And we have the accessory line for belt buckles, for ball tip pens, for musical instruments, for example. And there we have also some restrictions in the lead limit down to 90 ppm, which is the equivalent to 0.009%. So this is really lead-free. But going to the requirements from the water sector, on the left-hand side we see the requirements from the machining shops. Okay, they need to be able to produce a fitting or a tap or something else out of the pre-material. So they need machinability of the alloys, and they need hot formability if they do hot stamping or something like that. On the right-hand side, we see the requirements from the application itself. We need corrosion-resistant alloys because we would like to put them in a system and they maintain there for 50 years or longer. So they have to be very resistant in terms of corrosion, for example, erosion corrosion or disinkification corrosion. And last but definitely not least, there are some hygienic requirements, because nobody of us would like to drink drinking water with detrimental substances like lead in it. There are some further requirements like coatability, but these are not in the foreground. If we look at the application of the water sector, I guess fittings and tapware are the largest part of this business. And we can distinguish some alloys to current material and future material. In this case, current material are materials which are on a national hygienic list, so they can be applied on the market, and the future material will fulfill the requirements of the future European positive list. So these will be alloys which are really future-proof. We can distinguish them further in corrosion-resistant and standard brasses. The first one are standard brasses. They are not resistant to disinkification corrosion, for example. It's a CU-740 PB2. That's the more or less standard brass in the sanitary industry. And we can provide two alloys which are already lead-free today. and which are perfectly suitable for standard applications where there is no need for higher corrosion resistance. The first one, CU742, is the alloy Wieland Eco SZ4, so it's quite a new alloy. I come back to that later. The second alloy, CU736, silicon phosphorus, is also a silicon and phosphorus containing alloy. Some of you might know it under the brand name Glowbrass. At Wieland, we will promote this alloy as Eco SZ2. There is an asterisk in this case because the alloy is still being put in tests regarding the hygienic approval, but we expect the results beginning of next year. So I guess beginning to mid next year, it will be on the hygienic positive list, on the 4MS list. If we go further to the disinkification resistant alloys, CU736 PB2AS is one of the most important alloys in this sector, or basically it was. That's why I put it in brackets, because in a lot of markets it's not allowed to use that alloy anymore because the lead leaching of that alloy is quite big and do not fulfill the requirements of today. So we have some substitutes of that. There is also the first one in brackets. It's also an arsenic inhibited alloy, and there's also an asterisk on that because that alloy and the composition like it is today fulfill the requirements of today. That's okay, but it will not be able to fulfill the requirements of the European positive list, although it has just a lead content of 0.24%. So currently this alloy is on a test bench to see if we can reduce the lead limit down to below 0.10% and to achieve the lead leaching to 5 microgram per liter. So it's not sure if this alloy will maintain on the positive list. So on the draft status of the European positive list, which will be published beginning of next year, this alloy can't be found. So, and due to the lead limit reduction from 0.24% down to 0.10%, we will see a further drop in machinability, which makes that alloy even worse machinable. The next alloy, CU721, silicon-3 phosphorus, is also known as EcoBrass. It's, in my opinion, the only real future material, since this material is the only one of this list which is on the European positive list on the draft, and will be the only one of these ones which will be on the European positive list, which will be published beginning of next year. So the proof is already done. We have marketed that alloy since 2020, since 2007. We have it in the market, and we have very good feedback from customers on that alloy, and also there are some scrap cycles established on the silicon and phosphorus side. That's why we focus on that alloy, or on that alloying elements for further developments. To complete this overview, there is the CU735 SN1P. That's a quite new alloy. It was on the test bench. It was proved to have a low lead leaching to the drinking water. So this alloy will be on the on the 4MS list by end of the year. I guess it should be end of December. A new list from the Umweltbundesamt in Germany, as well as the 4MS list, and this alloy would also be added there. But it would be disinkification resistant, but not stress corrosion resistant, and it will be not that good machinable like we know it from EcoBrass. So there will be also a drop in machinability, and that's why the productivity declines. To make it complete, there are some red brasses, CU705 PB2, the standard CC499K. Also, this material won't be on the European positive list. That's why we are also providing some sulfur-containing alloys. If you use sulfur as a chip breaker, you have to maintain a very low zinc level. That's why we have high copper contents in that alloy, and that makes the alloy quite expensive itself. If we put that alloys on a table in regard to the machinability in terms of hot formability as well as machining. We see the green ones are the future metals, and for me the picture is quite promising. So we have a very small drop in machinability, so that's quite good, and we have more or less the same metal costs for some of the alternatives. So I'm coming to my last slide, and I hope you enjoy what I can show you. I would like to give you a sneak preview of 2024. We will release 2 new alloys in the ecosystem of Wieland, Eco SZ3 and Eco SZ4. These will be 2 new alloys in our portfolio, and they will be available in Q1 2024. So we are on the test bench with them to make them European positive list conformant and get them on the hygienic list. But we are convinced there will be no question they will be on the positive list by the end of the year 2024. Here you can see the different chip formation processes of the standard leaded brass with 3% lead in it, and 2 absolutely lead-free alloys. Lead-free in this case means lower than 0.1%, of course. We have in the middle, we have a silicon content of about 0.3% and a phosphorus content below 0.1%. And on the right-hand side, it is the alloy CU742 with some chip breakers in it, also phosphorus and silicon. And that's why we can maintain the high productivity with the standard leaded brasses. Here we used the same tooling. We have some projects running with WZL at the University of Aachen, which also confirmed us that the machinability of these 2 new alloys are quite good. And of course, the copper zinc ratio of these 2 new alloys is more or less the same like for the standard brass, which means in terms of metal costs, it is almost the same. So with this, for me, very promising outlook, I would like to thank you for your attention. And I'm happy for discussions. If you have any questions, please feel free to ask them. And if you would like, we will be happy to have you on our booth, Hall D. Come and discuss with us. Thank you.